This is the video lesson for projectile trajectory, velocity, and displacement. The learning target for this lesson is I am learning to describe a projectile's trajectory and to calculate its horizontal and vertical velocity and displacement. The success criteria for this lesson are I can describe a projectile's trajectory for horizontally and non-horizontally launched projectiles. I can calculate the horizontal and vertical velocity for a projectile, and I can calculate the horizontal and vertical displacement for a projectile. So here we're going to look at the trajectory of a projectile launched horizontally. So there's no vertical velocity for this projectile. So we can see it just comes out here and is launched horizontally. And here we'll look at it as it goes slowly. So you'll notice as it moves that the horizontal velocity vector is constant, but as it goes down, the velocity vector, the vertical velocity vector gets longer and longer as it moves down. So we have a constant horizontal velocity vector, but the vertical velocity vector is getting longer and longer as it accelerates towards the ground. So that is what a horizontally launched projectile trajectory is going to look like. All right, and here we're going to look at a trajectory for a projectile that's non-horizontally launched. So here we have an initial vertical velocity as well as an initial horizontal velocity. All right, so it starts to go up and then it goes back down again. So we start with a big vertical velocity, and the vertical velocity gets smaller as it goes up until it reaches its apex where there's no vertical velocity, only horizontal velocity. And then as it's going, the vertical velocity in the negative direction gets bigger and bigger. And so again, the horizontal velocity is going to stay the same. So we have the same horizontal velocity, but the vertical velocity starts in a positive direction and it's getting smaller as it goes up. And then at the top of the trajectory, there's no vertical velocity at all. So the projectile has stopped having any vertical motion right here at the top, and then it starts to accelerate downward. And so the vertical velocity is getting larger as it goes down. All right, so the horizontal velocity of projectiles is such that the horizontal velocity is constant for all projectiles. So the initial horizontal velocity is equal to the final horizontal velocity. So in any horizontal velocity trajectory, so whether we have a horizontally launched projectile or we have a projectile where it's non-horizontally launched, the horizontal velocity vector is going to be constant in any projectile motion. So that horizontal velocity vector is constant for any projectile. The vertical velocity of a projectile, on the other hand, changes based on the kinematics equations. So the kinematics equations we learned in the first unit, the vertical velocity changes based on those. So we have the equation v equals v naught plus the acceleration times time. It's going to govern the change of the vertical velocity. So we have acceleration, a, in this equation, is going to equal g, which is the constant, minus 9.8 meters per second squared. So this g is caused by gravity, and it causes everything to move towards the center of the earth. So any projectile is being pulled towards the ground, towards the center of earth at this rate, negative 9.8 meters per second squared. So for horizontally launched projectiles, the initial vertical velocity is going to be 0 meters per second squared. So if you think about the trajectory of a horizontally launched projectile, it starts off with no initial velocity. So you can think about a cannon on top of a hill or on top of a cliff, and it just launches it out horizontally. So there's no vertical velocity. On the other hand, for non-horizontally launched projectiles, the initial velocity is not zero. So it does not equal zero. So for that, we're talking about a trajectory that would look something like this. So it has a vertical velocity vector that is not zero because it's starting off going upwards. So it would have to have a non-zero vertical velocity vector. All right, so we're going to watch a little animation of vertical velocity of a projectile launched horizontally. So we're going to see the velocity vectors here. So you can see the horizontal velocity isn't changing, but the vertical velocity does change. The vertical velocity gets larger as it goes. So the vertical velocity vector is getting longer as it falls based on gravity. So here we're going to watch the vertical velocity of a projectile that's non-horizontally launched. So we have a positive vertical velocity at first, and then when it reaches the highest point, that vertical velocity is zero, and then as it starts to fall, the vertical velocity is going to increase again as gravity pulls it down to the ground. So we see the vertical velocity vector getting smaller as it goes up until it reaches its highest point. And then after that, it starts to get smaller or larger as it falls to the ground until it reaches its maximum length right before it hits the ground. All right, so here's an example. So we're going to find the horizontal velocity in this example. So a little boy wants to see how far he can throw a rock off a cliff that's 30 meters high. He throws the rock straight ahead off the cliff, so there's no vertical motion, with a horizontal velocity of 5 meters per second. And we want to know, what is the horizontal velocity after 2 seconds? So remember that our initial horizontal velocity, so I'm just going to write an IX here to note that it's in the horizontal direction, is equal to our final horizontal velocity. So our initial horizontal velocity is equal to 5 meters per second. So therefore, our final horizontal velocity is also going to be equal to 5 meters per second. Okay, in example 2, we're going to find the vertical velocity. So a little boy wants to see how far he can throw a rock off a 30-meter high cliff. Now he throws the rock off the cliff with a vertical velocity of 3.5 meters per second. And we want to know the vertical velocity after 2 seconds. Okay, so we need to know our vertical velocity formula. So our velocity in the y direction is going to be equal to our initial velocity in the y direction plus g times t. So g here is going to be equal to negative 9.8 meters per second squared, and our time is equal to 2 seconds. So we have Vy is equal to our initial velocity, which I didn't write up here, so let's write Voy is equal to 3.5 meters per second. So that's 3.5 meters per second plus minus 9.8 meters per second squared times 2 seconds. So that's going to be equal to, so we have 3.5 meters per second minus 19.6 meters per second. So our final velocity is equal to minus 16.1 meters per second after 2 seconds. All right, now we're going to talk about displacement. So how to figure out the displacement of the projectile. And in this case, we're going to look at the displacement of a projectile in the horizontal direction. So since the velocity is constant, we're going to use this equation, x equals v naught times t. So v naught is the initial velocity, and since velocity doesn't change, the initial velocity times time is going to give us the displacement for the horizontal displacement of the projectile. The vertical displacement of projectiles is a little bit more complicated. So remember, the only force acting on a projectile is gravity. And the acceleration due to gravity is negative 9.8 meters per second squared. So the only acceleration acting on a projectile ever is going to be g, and that's minus 9.8 meters per second squared. Okay, so for horizontally launched projectiles where there's no vertical velocity, there's no vertical initial velocity, the equation we're going to use is y equals 1/2 g times t squared. So y is our vertical displacement. G is the acceleration due to gravity. And t squared is the time squared. So this is for horizontally launched projectiles. For non-horizontally launched projectiles, this is the whole entirety of the kinematics equation. So this is y is equal to v naught in the y direction times time plus 1/2 gt squared. So we add to this initial equation that we used for horizontally launched projectiles, we add to it the initial vertical velocity. So we add to it the initial vertical velocity times time. All right, let's look at an example to find the horizontal displacement. So a little boy wants to see how far he can throw a rock off a 30-meter high cliff. He throws the rock straight ahead off the cliff, so there's no initial vertical motion. With a horizontal velocity of 5 meters per second, we want to know what is the horizontal displacement after 2 seconds. So let's write down what information we have. So we have a horizontal velocity. So we have v naught in the x direction is equal to 5 meters per second. We have time of 2 seconds, and we want to know our displacement x. So we have the equation written up here. X is equal to v naught, I'll write in the x direction, times t. So we're going to plug our information into the equation here. So v naught x is 5 meters per second times our time, that's 2 seconds. So after 2 seconds traveling at 5 meters per second, our displacement is 10 meters. So if we draw a little diagram here, we've got our cliff edge and we've got this rock thrown off the side here. And this is going to be the horizontal displacement, x. So the rock is going here. And so let's say this is 1 second and this is 2 seconds. So the distance from here to here after 2 seconds is 10 meters. All right, so now we want to figure out the vertical displacement when the projectile is horizontally launched. So this is example number 2. So we have a little boy who wants to see how far he can throw a rock off a 30-meter high cliff. He throws the rock straight ahead off the cliff. So again, there's no initial vertical velocity. And we want to know what is the vertical displacement after 2 seconds. Okay, so our equation I've got written up there in the corner is y equals 1/2 g times t squared. So our t here is 2 seconds. Our g is a constant. It's always negative 9.8 meters per second squared. So to figure out our vertical displacement, we have y is equal to 1/2 times negative 9.8 meters per second squared. We're going to multiply that times 2 seconds. We're going to square that. And that is going to give us a vertical displacement of negative 19.6 meters. So if we draw a little diagram again, so we've got our cliff face, we've got our rock, so that's 1 second, there's 2 seconds, 3 seconds, 4 seconds, so 1 second, 2 seconds, so this distance between 1 and 2 seconds here is 19.6 meters, negative 19.6 meters. All right, example number 3. Find the vertical displacement of a non-horizontally launched projectile. A little boy wants to see how far he can throw a rock off a 30-meter high cliff. Now he throws the rock off the cliff with a vertical velocity of 3.5 meters per second. What is the vertical displacement again after 2 seconds? So let's draw a diagram here. So now instead of throwing the rock off the cliff with no horizontal or with no vertical velocity, he's going to throw it off with a vertical velocity. So the projectile is going to take a trajectory that looks something like that. So we want to know what's the position after 2 seconds. So we've got some information here that we need to look at. So V naught Y is going to equal 3.5 meters per second. Our time is going to equal 2 seconds. G, again, is a constant, negative 9.8 meters per second squared. Let's plug this into our formula that we have right here. So displacement Y is equal to V naught Y times T plus 1/2 times G times T squared. So we have Y is equal to 3.5 meters per second times 2 seconds plus 1/2 times negative 9.8 meters per second squared times 2 seconds squared. So we have 7 meters minus 19.6 meters, which gives us a total displacement of minus 12.6 meters. So I need to modify my drawing a little bit. So this is 1 second. The rock goes up and then comes back down. And so this would be about 2 seconds. So here's 1 second, here's 2 seconds. And that distance between these 2 points is about negative 12.6 meters. All right, everybody, keep asking questions. It's how you learn new things.